All right. Today we introduce the course Math 201, Maths Methods 1. That's the course title. Maths Methods 1, and the contents are already on the course outline and lecture notes. So we look at the first thing in the course content: revision of differentiation and integration. The reason is that every topic we will come across in maths method has something to do with differentiation, and they go hand in hand. That's differentiation and integration. So we start with differentiation. It is the rate if you are given a function for y equal to 4x cubed, and we want to look at the rate at which y changes with respect to x. We have two variables here. We have y and we have x. So a change in x could bring about a change in y. That is where we assign values to x. If x is equal to 1, then y is 4. If x is equal to 2, you discover that y is 32. So we notice that a change in x brings about a change in y. When the value of x changed from 1 to 2, that of y changed from 4 to 2. The rate at which y changes with respect to x is differentiation, and that is what we denote as the y over the x. So we can actually calculate this rate using what we learned in our 100 level elementary mathematics, where we said that given any function a(xn), that the y over the x, where a and n are constants, and a not equal to 0. So we have, if we have a dot ax raised to power n, then the y dx is a dot n x raised to power n minus 1. We derived this answer in our previous classes. So this could be simplified as a n x n minus 1. So this is what we call derivative. We call this derivative of y with respect to x. So the y dx, if we use that idea, we use the power of x to multiply the coefficient of x, that is a dot n, then we remove 1 from the power of x. So the rate at which y changes with respect to x is 12x squared. 3, 4 is 12, then subtract 1. Remember, we call this the gradient function. We called the gradient function. So if we have another function, for example 4, we said that this is the same thing. Y equal to 4 means y equal to 4x raised to power 0. So by the time we find the y, the x, you know that 0 will multiply everything here to give us 0. So when you differentiate a constant, 4 is a constant. If you differentiate a constant, you will have 0. So this will take us to some other examples we handled. Remember, we are trying to revise differentiation and integration. Both are important tools in math methods. Both are very important tools in mathematical methods. So we continue with more examples, just to refresh our memory of what we did earlier. So we look at an example like this given, let's call this question 3 now. Given y equal to x plus 4 into x squared plus 3, and we are asked to find the y, the x. Another way of writing the y over the x could be y prime. So you can also see f prime of x, for looking at the fact that y is a function of x. So find the y, the x, find y prime, find f prime of x. Alright, so in some questions you may not see y, you may see f of x equal to x plus 4, x squared plus 2. So if you want to differentiate this, the y, the x, so we go on here, we expand x and this will give you x raised to power 3. This and this will give you 3x. This will give you 4x squared. This will give you 12. So that we have the y, the x. Sorry, we are still having the function y. So we now have x cubed plus 4x squared plus 3x plus 12. Please, this is still the same as this. I only expanded. I had to rewrite it in an expanded form so that I can now differentiate. If I want to differentiate now the y, the x, use the rule we know. This will give us 3x squared, this will give us 8x, and then this will give us 3. So this is the gradient function for this. Alright. We also learned the product rule for differentiating something like this. We learned the product rule. Since this is a function, we can call it u, and this is another function, we can call it v. The product rule for getting the derivative of two functions which are multiplying each other is that the y, the x, is v the u plus u dv. Of course, this is the x and this is the x. So that means if I want to handle this same question, when you are asked to differentiate y x plus 4 and x squared plus 3, we will have, say, let u be x plus 4 and let v be x squared plus 3. So from here we need to obtain du dx. Du dx. That gives us 1. I need to obtain dv dx. This gives us 2x. Such that I can now use the rule, which means looking for the y dx is using v. We use v to multiply derivative of u. That brings in v, which is x squared plus 3, multiplying du, which is 1, plus we bring in u, which is x plus 4, multiplying dv, which is 2x. So we have the y dx is this will give us x squared plus 3, and then if I bring in this, I'll be having a 2x squared plus 8x plus 8x, so that I have the y, the x, so that I have the y, the x equal to 3x squared plus 8x, then plus 3. You'll notice I have the same thing as when I expanded. So that's product rule. We also looked at the quotient rule of differentiation. Quotient rule. Product answer gotten after multiplication. Quotient rule. If I have two functions of this form, u over v, I can as well use a quotient rule or rewrite the function. So I'll give an example. If you are asked to differentiate y equal to 1 over x squared, now what we know is that this is the same as x raised to power minus 2. So if I want to find the y, the x, if I want to find the y, the x, I will use the power of x, which is minus 2, multiply this to give minus 2x. We subtract 1 here to have minus 3, such that I'm having minus 2 over x raised to power 3 as the answer. Alternatively, we can treat this y over x squared as a quotient of two functions. We have a numerator, which is 1. We have a denominator, which is x squared. So we could use the quotient rule, and I want to introduce the rule. So if you have a function to differentiate and you discover it involves division of other two functions, then we can use the quotient rule, which states that giving y equal to u over v, to get the y over the x, or we have v du, that's v du over the x minus u dv over the x all over v squared. So that's the quotient rule for differentiation, such that for the question we are considering, my u, let u be the numerator, which is 1, and our v is denominator, which is x squared. So this makes us to have du dx. If I differentiate 1, I'll be having 0. Differentiate v, dv dx, I'll be having 2x. So if I substitute these into the quotient rule or quotient formula, I'll be having the y dx equal to v is x squared multiplying du is 0 minus u is 1 multiplying dv, which is 2x over v squared. Recall my v is x squared, then all squared, such that we have the y dx as minus 2x over x raised to power 4. This reduces to minus 2 over x cubed. You confirm it's the same answer we had earlier. So that's quotient rule. We take another thing. That's differentiation composite functions, or differentiation involving function of function. Alright, let's take a look at this again. The product rule, if I have y equal to uv, I can get the y dx using the y dx equal to v du plus u dv. And if I have quotient rule, I have a function of two functions dividing each other, then I will bring in the quotient rule, which is this. Alright, we look at differentiation of composite functions. Some call it function of functions. Okay, consider this function. Consider the function y equal to x plus x squared plus 4 raised to power 2, x squared plus 4 raised to power 2. If we are to obtain the gradient function, that is, obtain the y dx. Let's use the method we know. So given y as x squared plus 4 all squared, to differentiate this, we rewrite. So we expand. Let's expand this so that we will have y equal to x squared plus 4 multiplying x squared plus 4. This gives us y equal to this and this. We give us x raised to power 4. This and this. We give us 4x squared. This and this. We give us 4x squared. This and this. We give us 16. Such that we now have y as x raised to power 4 plus 8x squared. These two. Then plus 16. This is what we have. Now, this is the same as this. I can get the y dx from this. So differentiate x raised to power 4, you will have 4x raised to power 3. Differentiate 8x squared, you will have 16x. Differentiate plus 16, it gives you 0. So this is the y dx. That's the gradient function. What we are trying to look at is a situation where, what if I have y equal to x squared plus 4 raised to power 7? Does it mean I will have to expand 7 times? When it was power 2, I had to write the function 2 times. I multiplied twice. Now, if you have power 7, you will discover the problem with this method. It means I will have to write x squared plus 4 x squared plus 4, x squared plus 4 into 7 times. That will be very tedious and cumbersome, and we may end up making a mistake at some point. So we look at a way of obtaining the gradient function when the power is higher, when we can't easily expand the function. So example is this one. If you are asked to differentiate y equal to x squared plus 4 raised to power 7, this brings us to the chain rule of differentiation. The chain rule, where you have to bring in another function for this. So that's why some books call this function of function or composite function, or simply chain rule of differentiation. Now I will use the chain rule for the first example so that you confirm it works for other ones we will come across. Now we'll come to this side. Remember, we handled y equal to x squared plus 4 all raised to power 2 using expansion. We differentiated this by expanding. Now what we want to do is not expand, and we try to obtain the gradient function. Now look at the idea. My problem is this. Remember that if I had y equal to u squared, getting the y du is not a problem. So from here, the y du is simply 2u. So I have something here which is not as simple as u. So what we do is that we introduce a single letter to represent this. That's why we say let u be x squared plus 4. So I know that if I had only y equal to x squared, the y, the x will not be a problem. It's simply 2x. So this is a single letter. This is not a single letter. So we try to make this a single letter. We bring in a single letter to represent this. Since we already have this function in x, I will use x. So we say let u be x squared plus 4. This means that I have changed the question to y equal to u raised to power 2. That means you have removed x squared plus 4 and you're using u for it. So let u be x squared plus 4. Then the question has changed to y equal to u raised to power 2. Such that for you to have u and x squared plus 4, this is a function, please. U is now a function of x, y is now a function of u. But the original question had y as a function of x. So we have y, which is a function of u, y, which is a function of u, where u is a function of x, y a function of u, and u a function of x. That means y is a function of a function. Y is a function of a function. So what we do is to find the rate at which u changes with respect to x. That is du dx. Obtain du dx, and that will give x here. Also come here, obtain the y du. That will give 2u. Recall that for the product, a chain rule problem like this, if we are looking for the y dx, we have the y du. We have the u dx. I want to obtain the y dx, but I have these two. I have the y du and I have the u dx, and I want to obtain the y dx. So multiplication would give us the y dx, because the u will handle the u. So this is what we call chain rule of differentiation. So we call this a chain rule for this problem. So dy du times du dx. Remember, there were some problems we handled in our first year where multiplication was not used. Instead, we used division. All right. So we have the x now, the y du with 2u times dx, which gives 2x. So our answer is the y over equal to 4ux. And the y du, y should be a x. So we have to return u to be in terms of x. So this means 4x into, which is x squared plus 4.
I have is 4x. So this x is this, u is this. My answer my answer should be y and x. So we return to what it represented. So 4x times x squared is 4x times 4 is 16x. So this is the same is longer than the previous one. Ideal approach to use the power is 2. So let's take the question we left. Have y equal to x squared plus 4 raised to power, and I'm asked to differentiate, introduce letter. Let x squared. That means I have changed the question to y equal to u raised to the power. So du the 2x and the y u, whatever u is. For the y the x, obtain it from the times the u the x. The y the x, the u, which is 7 times the u the x. This gives u. So if I multiply x 4 power 6. So this is derivative for x squared to the power 7. We continue. Alright. Differentiation of exponential. Differentiation of exponential function. Y e a x dy dx a b dx a k constant constant a k. Let's take a complete equation equals example following follow with x. Y is exponential 2 is equal to exponential minus 2 3 equal exponential. Look at the log constant differentiate have A. If you have A, what prime is minus 2 exponent have 2 function 2 and let here the x is x such x u x plus v which is the y research so number 3 your question your comment respect to x. Alright, let's see this. The same approach I can bring out is to have 4 integral of 1 over x minus 1, 4 integral 1 over x minus 1 with respect to x. So differentiating denominator gives us exactly numerator. So that means we have 4 lane x minus 1 plus c. This is also lane x minus 1 raised to the power 4 plus c. All right. So these examples uh, deal with integration when the denominator and numerator are related by differentiation. Okay, we look at how to integrate exponential functions, integration of exponential functions, integration of exponential functions, integration of exponential functions, integration of exponential functions. Number one, integrate, the rule is this: if I want to integrate exponential ax with respect to x, we have differentiate this, you have a. So exponential ax over a plus c, where a is a constant. All right, examples on that. Examples, we have integrate the following. Integrate the following. Number one, exponential 2x with respect to x. Number two, exponential minus 3x with respect to x. Two questions would be okay to deal with that. So number one, if you are asked to integrate exponential 2x with respect to x, differentiate 2x, you will have 2. So we are dividing with the 2, and we repeat exponential 2x plus c. Alright, so for number 2, integrate exponential minus 3x with respect to x. So differentiate this, we'll have minus 3, and we repeat exponential minus 3x plus c. This is the same thing as negative of this one over 3 plus c, which is still the same as 1 over 3 exponential 3x plus c. Alright, so that's for integration of uh, some integration of functions. We just want to deal with this one so that we can get to the main things in the topic. Alright.